Angular motion. Question? Simple harmonic motion. Question? Question 1. Okay. Do you think my answers are wrong? Okay, no problem. We got? Yeah?
I don't know how to use that.
Okay, no problem. Let's have a look. No problem. Simple harmonic motion, question 1. A 50-gram bob is hanging from the ceiling. Oh, sorry, it's hanging from the ceiling. And it's a touch. Okay, and the girl pulls it down 6 centimeters. So she pulls it down 6 centimeters, and then it begins to vibrate up and down. So it'll go up and down, up and down, up and down, like this. And the frequency is 2 hertz. What is the amplitude? Amplitude here is 6 centimeters. Yeah. B. What is the time? The time is 1 over f, which is 1 over 2, which is half a second. So far so good? C. What is the angular velocity? Omega is 2 pi over t, which is 2 pi over a half, which is 4 pi, which is 12.57 radians a second. D. What is the maximum acceleration? Well, the formula for acceleration is minus omega squared x. But since we want the maximum, we'll just take the positive. And the biggest the x could possibly be is a, the amplitude. It's the biggest the x could be. So the biggest the acceleration could be is this. So that's 12.57 squared times 0.06, which I hope is 9.47 meters per second squared. Yeah? E, what's the maximum velocity? Well, you have the formula for velocity. What is it? Plus minus omega? A squared minus x squared. This is biggest when the x is 0 because it makes the inside bigger. So that will be this, which will be this, which will be 12.57 times 0.06, which is 0.754 meters per second. F. How fast is the bob moving after 0.1 of a second? So we have to use the formula A sine omega sine omega t. This is in your formula book. The A is 0.06, the omega is 12.57, the sine of 12.57 times 0.1 is 1.257. So, as long as you're in radiant mode, you'll get this, I think. G, what's the acceleration? What would be the best formula? You could say acceleration is minus omega squared x, but we need to figure out what the x is, and we have a formula for x. It's a sine, a cos. It starts on the outside. But I should put a minus here because it starts underneath. Like at the beginning, the x is minus 0.06. So I think I should put a minus there.
And why is not the a omega sine minus?
This one?
Yeah.
Yeah, I'm sorry, that should be a minus as well. Although, did I ask for speed? Yeah, I asked for how fast, so I don't care about the minus, yeah. So that's omega squared A cos omega t, which is 12.57 squared, 0.06 cos cos 1.257. So that should all be positive. So that's 2.93 meters per second squared. Oh, okay. And then actually I should have done h first, because h is asking me for the x. So the x equals minus a cos omega t, which is minus 0.06 cos 1.257. That's equal to minus 0.019. Now, if you think about it, if its displacement is minus 0.019 and it begins its journey at minus 0.06, it means it's moved up 0.041. So it moved up 4.1 centimeters. Okay, so this was a hard question. It was a section B question a while ago, I think. More zooming out. How about that? Got that? H? Okay.
0.019. Why is s equal to minus a cos omega t?
Yeah, it's usually plus, but because you pull this bob down and it starts under the axis, I have to flip the sign. not the end of the world if you don't, you know. What's next after this when you're ready?
So for part H, is it negative 0.06 cosine 1.257?
Yeah. What did you get? Are you in radian mode? Dang. Mm-hmm. Mm-hmm. Cantilevers, question 3 next. Yeah. Yeah. Okay. Dun, 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 dun. A braced cantilever iron beam is supported by a 13 centimeter stay. So here to here is 13 centimeters. Oh goodness. This here is 5 centimeters. So then this guy has to be 12 centimeters. In total, it's 15 centimeters. So that means this piece here has to be 3 centimeters. Is that okay so far? The weight is in the middle. So half of, isn't it 15 long? Yeah, 15 long. So that means here is 7.5 centimeters, and this one is also 7.5 because it has to be in the middle. Okay. So you have how many forces? You got a weight. What's the mass? 5. Oh, yeah, no, it's 20. So that's 20 G. You've got a tension, and you've got your reaction here. Okay. Now, let's zoom out a bit. I think I would like to use Lamy's theorem here to help me, because I have 3 forces. No, let's not use Lamy because we don't know about Lamy until the next page, so we won't use Lamy just yet. So there's 2 forces here, an X and a Y. I'll just call it X and Y. And this angle here, we could know this angle, because if I draw the triangle here, it's 13, 5, and 12. So in degree mode, what's tan inverse 5 over 12?
Degree?
Yeah.
22.6.
22.6 degrees? That's the angle here. Okay? So you can have a T cos and a T sine. So let's look at our equations. I can say y, the vertical part here, plus T sine 22.6, that should equal 20G. I can also say X should equal T cos 22.6 by looking horizontally. Yes, no? What do we think? How can I get my last equation? I need one more. Okay, yeah. X plus y equal X plus T. X. y plus t. We've done that one.
Oh,
Y
okay.
plus t sine is 20g. Yeah. So what's the other one?
T sine times the length.
T no. Well, yeah, the turning force.
Okay.
Where will we take our turning point? I'll take it here. Okay. So is this guy clockwise or anti-clockwise? Clockwise. This one we don't care. This one here? Anti. So those two should equal. Okay. So 20g times 0.075. That should equal. Now what's the distance from here to here? 12, isn't it? Times t sine 22.6. Now that's really good, because what will this equation give me? What can I work out from this one? T. And then once I know t, what can I get from this one? This one, second one? X. And then lastly I can get y. So t is 20g times 0.075 over 0.12 sine 22.6. Say again?
318.8.
Newtons. That's a bit different to my answer here. I got 303. Didn't I? Oh well. Can I trust you on this?
Yeah.
We can trust him?
I got 319.
I got 09.
Maybe my answer's wrong here.
I think we have that tutorial before.
Yeah.
That's 319.
Yeah. Okay. Can you give me a pen so I can remember to change the answer here? So it should have been 319, not 303. Okay. And what about the x and the y now? So can someone type in x equals 318.8 cos 22.6? What's that? And then y equals 20 times 9.81 minus 318.8 sine 22.6. You are in degree mode, aren't you? Okay. What's the x and the y? The same, is it?
73.6.
For the nearly the same. Are you sure? That would mean my answer's way off then. This is
22.6, right?
Yep. 73.6 for the y. Oh, then my answer here is totally off then, because the last part is to get the angle here. So if you look, we know the x and the y.
Oh,
Huh?
for the X,
Yeah?
I got 294.3, sorry.
Okay. That doesn't affect this answer. What did you get?
294.3.
Okay, that's better, thank you. So, this is 294.3, and this is 73.6, and I want the angle here. So what do I do to get the angle? This angle, how do I get that? Oh, no. The angle. The angle.
Tan inverse.
Tan inverse, thank you, Joe. Tan inverse 73.6 over 294.3. What's that? Where's your calculator, Joe? Thank you. Mm-hmm. About 14 degrees? What is it?
14.04.
Ah, so my angle's exactly right. Mystery. So 14.04 degrees. No.
Is that
73.6. Yeah, sorry, it's the Y answer. Got that? Yeah. What will we do next?
There's still sub question.
Okay. But all it is just okay. There's an extra part where you just stick on a 5g at the end here. So it just means your equations. Can I scroll a little to the left? Your equations now become this: y plus t sine 22.6 equals 25g. X is still equal to t cos 22.6, and then the turning force, you'll have 20g times 0.075 plus 0.15 times 5g equals 0.12 t sine 22.6. So it's practically the same. You'll get now t will be 20g times 0.075 plus 0.15 times 5g all over 0.12 sine 22.6. So this should be a bigger tension now.
5G plus
5g. That plus 0.15 times 5g.
Why not 25?
This is the 20. Yeah, this one is you're adding the two turning forces. So I did a 20g times 7.5 and 5g times 15. No, the 25 was in the first one when you did y plus the t sine equals 25. Yeah. So when you're ready, you can tell me the t here. 478 by 2?
478.2.
Oh, 0.2, sorry. Okay, so we got our t. Then we can put that back in to get the x. So the x would be 478.2 times cos 22.6. So that gives us the x now, which is 441.5 newtons. And then finally we can get the y. The y is 25g minus t sine 22.6. So now I have the y. Oh wait, stop! Sorry, the question is only asking what the t is, so stop there. I did enough. What's next? Lamy. Which Lamy? Lamy number 3. Yep. Scroll down. Yeah? Mm-hmm. Sleepy? Look at you all, also sleepy. We got class after this?
Do we have the math today? 'Cause I came in last Thursday and.
Yeah, but you don't have to go to, because you're not in the extra class anymore.
Really?
Yeah, because I think your test result was quite good. So, you can go off home and enjoy your break like the rest of the class. Is this surprising, good or bad news? Yeah, I thought so too. Ready there? Yeah. Yeah, you did a lot better in your mid-semester than in your entry test.
Because most of the things in the entry test I haven't taken so far.
Really?
I'm not bad at math, I just didn't do all the things.
Okay. Well, it was a little bit of a mystery how different the two results were, you know? Like Joan was telling me your results, I'm like, that's really good.
It was a good result.
It was a good result, I think, yeah. Unless I'm mixing you up with another SIVA. I think you're the only SIVA, right? Okay. Number 3. This is from Lamy's. Now I hope I'm not mixing you up, so don't be disappointed then if Joan says...
No, because I think it's pretty good in the exam.
Yeah, you were happy with how it went. Yeah, okay. A 10-meter ladder of mass 20 is against a smooth, wet wall. The base is 8 from the wall. So what you have here is a ladder here. This is 10 meters, and this side is 8 meters. So Pythagoras says this one must be 6. So you know here there's a force. How big is this ladder? 20. So that's 20G. There's a reaction here, and there's a reaction here. And I want this angle. So Lamy says that these 3 should all meet. That's a meet point there. So if I draw that triangle, we know that this is a 4 and this is a 6. So this angle here for part A is just whatever tan inverse 6 over 4 is, which I guess is 53.3 degrees. What's wrong? Looks easy now, doesn't it? What is the value of or? Okay, so look. If you resolve this way and this one is or cos and this one is or sine. or sine 53.3. But or sine 53.3, that should equal what? What should that equal? Yeah, it should, oh flip. Oh no! Go, cancel. It should equal, what did you say? Oh, not 8, no. 20g, yeah. So then the or is whatever 20g over sine 53.3 is.
So 144.
Say again?
144.7.
Okay. And finally, part C is what is this part here. This is the friction. The answer is, it's going to be or cos 53.3. Actually, we know the or, it's 244.7 cos 53.3. So the answer there is... Are you sure the last... my answers are all slightly off. I got 235.8 for the last one. Although I think it's because I used 53.31 degrees. What did you get here, Siva? For this one? What did you get?
146.2.
Okay. My answers are quite different. I think it's because in my book I must have used 53.31. I didn't think it would make much of a difference, but it seems to. Is this okay, Matt? Are you disappointed? Disappointed?
On myself?
No, no. No. No, of course not. That's not what I meant. Disappointed with the question. Okay. No, there's no judging here. It's okay. Okay, what's next now? What's next?
Circular motion, question 6.
Ba-ba-ba-bam. Okay. Circular motion number 6 next. Can I scroll down? Yeah. Number 6. A boy swings a 2-kilogram ball resting on a table in a horizontal circle. He uses a 13 centimeter string. Okay, so this is kind of hard to picture, but there's a string and it's 13 centimeters, and this distance here is 12 centimeters, and it's being swung around on a table. And this is 5 centimeters, obviously, and the periodic time is 0.7133 seconds. And is the table smooth or rough? So there's no friction. That's good. Okay, so look. How many forces are acting on this mass? What is the mass of it? Do we know? 2. Okay. How many forces are acting on it? What's the first one? 2G, yeah. What else? Tension. And what else? There's one more still.
Reaction.
Yeah. And this T can be written as T cos and T sine. So this is T cos. Now we have to get the angle. The angle is tan inverse 12 over 5. What's that, please? And this one here is T sine 67.38. Now, are you happy if I say t sine 67.38 plus or should equal 2g? And t cos 67.38, what type of force is that? The centripetal force, because it's making it turn in a circle. So we could say that's equal to m omega squared or, using the formulas from circular motion. Yeah? Okay. Now, we actually know some of the numbers here. So, the first one I can change that into t sine 67.38 plus or equals 19.62. And the second one is t cos 67.38 equals m, and omega is 2 pi over t, and the radius is 0.05. That's actually really good, because what can the second equation give me? What can I figure out from the second equation? 1, 2. I can get t, can't I? So I can say t, is that what I'm looking for? Yeah, great. So I don't even need the first equation. So I get t is whatever this thing is over cos. Okay.
Can I just draw the picture?
My beautiful picture, yes. Tell me, wonderful students, would you like to do a practice test now? And when I say practice test, I mean I'm not going to take it off you and, judge you. Just, do you want to do it? Huh?
I'm going to judge myself.
Yeah, but don't you want to know what you don't know and do know? You're not happy with this idea. I could put the test on Moodle and you can do it now.
Do it now?
Yeah, why not?
Can we do it home? Maybe at night?
When no one's looking. What? People really don't want to do a test right now. Like,
I feel like we need to look over more, study.
Want to do more? Yeah, that's no problem. That's no problem.
Can we do it
No, because I don't want to do
after
a
we
test.
study? Like, is it going to be still available on Moodle? That would help.
I can put it up for you to do at home if you like.
With answers?
Yeah, I think I'll have it give you the answers after you submit it. Yeah.
How about we pick a day we all do it?
That's fine. Yeah.
So we all finish actually studying before.
Yeah, because I can set the time. So what time do you want me to set it? Like open close time?
Friday's good.
At the end of the week.
Yeah.
What time? Quiz will open at 3 o'clock? It's only going to be a 1 hour test. So
Yeah.
I can open at 3. You can do it. You can submit your answers, then you can see them when you get right. Yeah?
What if you miss it?
What do you mean?
No.
Oh, if you can't start it at 3, I'll keep it open from like 3 o'clock to 6 o'clock or something. Yeah. So. What are we doing next?
The question 7 for circular motion will not come out, right?
Oh no, never in 100 years will that come up. No. No. Yeah, I think I need to go too. Is there anything you can be doing for a couple of minutes? What question are we doing next?
Can I go?
Simple.
Yes? Yes? Huh? Simple harmonic? Which one? Okay, let me just go to the bathroom. When I come back, we'll do all of them, okay? Why don't you get a start on them? See, maybe you'll surprise yourself and you can do them, okay? I'll start with number 2 when I come back then, right? Was it really that bad? The simple harmonic motion.
I don't know how to use the formula.
The formula, using the formulas is difficult. Yeah. Okay, we'll start with number 2. Just give me a minute, I'll be back. Yeah.
Supposed to be doing it like you guys did it on. Yeah. But they're gonna win. This is lots of free time.
Okay. Question 2. I lost George and Seba. Okay. Number 2 here. A spring bobs left and right from equilibrium position with a time of 6.283 seconds and has a maximum displacement, and do you mind, thank you so much, of 20 centimeters. What? George, you can see him? How was I quicker than you, Siva? I left after you. You walk slow, I think. Okay. How far from equilibrium? So what's the x when the v is 12? Okay, centimeters per second. So that would be 0.12. So let's imagine it starts here, okay? And it goes left and right, like that. Somebody tell me, when will the v be 0.12? When it's like, if I was to mark it off as 4 parts of the journey, A, B, C, and D, in what part of the journey will the v be 12? What do you think? In A, B, C, or D? And it starts here.
The vertical line is equilibrium.
Yeah, yeah. When do we think? Well, which? Come on, don't be shy. You're going with D? Mm-hmm. Any other answers? There's actually 2 answers, so. No. This is a picture question. Look at the picture. When do you think?
It starts from the equilibrium.
Does it?
Yeah.
Okay, well, it doesn't matter if it starts there. Okay, fine. If it makes you feel better. No. It's okay. Alright, it starts here, yes? And we'll say it goes right, and then back again, and then back to the start. So we'll say this is A, then B, then C, then D. Okay, now, tell me, when will it have a velocity of 0.12? In A, because it's heading to the right, and then again in D. So there's potentially two answers here, okay? Now, what's our formula for V? I think we have something like V squared equals omega squared A squared minus X squared. Is that the formula? Is it?
You gave us
I gave it as a root, did I? Yeah. But it's the same thing as this. Yeah. I gave it to you like V equals plus or minus omega root A squared minus X squared. Yeah. Now look, I'm looking for the X, alright? What do I know? So I'm looking for the X. Do I know the amplitude? Yes or no?
Yes.
I do. Yeah. Do I know the V?
No.
Do I know the V? No, I do. Because,
No.
yeah. And do I know the omega? Do I know omega? Yeah. I could use 2 pi over t. So, could I get the x? Of course I can, because there's only one unknown. So you can say 0.12 equals plus or minus 2 pi over t. What did I say the t was? 283, was it? Square root a squared minus x squared. Oh, and the a is 0.2 squared minus x squared. Now look, there's 2 answers here because of the plus and the minus. But didn't we say at the beginning we think there's 2 answers? Yeah? So the reason I gave you the time of 6.28 is because that's the same as 2 pi, so they cancel. Okay? Now, how do I get rid of a square root? How would I cancel a square root? Yeah. No, I'm not trying to trick you. It's just, I want a conversation, you know, we work on it together. So 0.12 squared equals 0.2 squared minus x squared. Yeah? So that means x squared equals 0.2 squared minus 0.12 squared. So that means x equals plus or minus the square root of 0.2 squared minus 0.12 squared. So that's plus or minus the square root of 0.04 minus 0.0144 or something. One of you will tell me, I'm sure.
Zero point zero one four four.
0.0144.
The answer is 0.16.
Oh.
That sounds a bit better. 0.16. You forgot the square root?
They faster
Hmm? Yep.
Oh.
Yeah, so if it just says how far, I don't care about the minus signs. And now part B, I want to get the time for this position. So if I use the formula x equals a sine omega t, I can get plus or minus 0.16, but I won't care about the minus, so 0.16 equals 0.2 sine. Now we worked out the omega earlier. The omega was 2 pi over t, which is 1 actually, so it's just sine t here. So the t will be in radian mode sine inverse 0.16 over 0.20, which is 0.9273 seconds, huh?
When do you use radian in physics?
Whenever you're using the formula a sine omega t or a cos omega t is radians. Okay. Number 3. Number 3. The column reply to my text. I'll text him in a minute. Okay. A particle of mass 100 grams is moving with simple harmonic motions. So its speeds are 3 meters per second, and then later it'll be 4 meters per second. When its distances are 2 meters and 1.5 meters. Now there's a problem here with the signs because I'm talking about speeds. So I don't actually know if it's plus or minus. So we need to draw the picture here. So look up. So there's the equilibrium. So let's imagine it's here at 2 meters. Its speed is 3. Is it heading right or left? We don't know. It could be heading right or left. So we'll just draw it as if it's heading to the right with 3 meters per second. Now, here, when it's at 1.5, its speed is 4 meters per second. That makes sense, doesn't it? Because it should be slowing down as it moves out. So I think the picture's okay. Right, and we have all these things to find. It's quite difficult because we don't have a lot. But we do have 2 points, and which formula has our v and our x in it? It's this one, isn't it? V equals plus minus omega square root a squared minus x squared. Now I don't like the plus minus, so I'll square. Now let me sub in the 2 points of information. So if I sub in the first one, I'll get 9 equals omega squared a squared minus 2 squared. And if I sub in the next one, I'll get 16 equals omega squared a squared minus 1.5 squared is 9 over 4, which is 2.25, is it? So I've made these 2 equations. And how many unknowns do I have? 2. So I should be able to solve this, right? But it's a little bit tricky. How would you solve this? What would you do? We could, but sadly it'll make it harder.
Calculate time.
The time? We could, but there's something easier to do. Yeah, but how? How should I solve these 2 equations? How should I put them together? Substitute what? Like what way around? You're close, Siva. Come on, what do you think?
So we just move the a squared minus 4 to the other side, so it will be 9 divided by a squared root 4, so we have divided for w squared.
Yeah, that would do it. So what you could do is this one you could write it as omega squared equals 9 over a squared minus 4. And this one here you can write omega squared equals 16 over a squared minus 2.25. And then what would you do? Yeah, make them equal. Yeah, substitute. So 9 over a squared minus 4 equals 16 over a squared minus 2.25. Then what would you do? Yeah, okay. I'll let you give me the a here. I think you can do this, yeah? You got the amplitude is 2.48. There might be a small rounding error here because I got 2.5.
Yeah, it's 2.48.
Yeah, okay, 2.5. Right, how can you get the omega now, which is part 2? How can we get omega? Yeah, how can I get omega? Come on, don't leave me hanging here. How do I get the omega? No, 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 look at the screen. How do I get the omega?
Put in the formula.
There we go. Thank you, Siva. So omega is square root 9 over a squared minus 4. And you know the a. So tell me the omega. Oh, that's not part B, but I still need it. Okay, now look, part B. How do I get the periodic time? That's 2 pi over omega, so that's 3.14 seconds. Right, C. How do I get the average speed? The average speed. So what's the formula for average speed? What's the formula? Yep. Total distance over total time. Now, what is the total distance? What's total distance here? What is it? Say again? 3.5? Because you're looking at 2 and 1.5. Nope. I should be clearer. When I say total distance, I mean for one full cycle. So, what's that?
7.
How'd you get 7 now? No, not 7. No, I'm just wondering how you got 7.
No, never mind.
What? No, what? Tell me.
I was thinking.
Yeah, but why? Why 7? Where did 7 come from? I would love to know. You didn't just imagine, both of you imagined the number 7. So, what was your logic? Tell me. No, what was your logic? You said 7 too.
I don't know my logic was. I think both sides I multiplied by 2.
Multiplied what by 2 though?
3.5.
But where's 3.5?
No, that's not 3.5.
Okay. Right, anyone has another answer? It's not 7 and it's not 3.5.
Total distance.
Total distance for one cycle, what is it? You can see it, it's on the screen somewhere, you can work it out. Total distance for one cycle.
5.
Nope. You answered too quickly, you're not thinking. And you have the right idea, but you're not thinking.
10.
You also have the right idea, but you're not quite thinking. It's 10. Because if the amplitude is 2.5, then it goes 2.5, 2.5, 2.5, 2.5. It's 10. Yeah? So, total distance over total time. Okay. D. What's the maximum velocity? Well, we've seen this question before. It ends up being A omega, which is 2.5 times, what was the omega? There, 2. So that's 5. E, the maximum acceleration, we saw this one before as well. It's omega squared A. So that ends up being 10 meters per second squared. Siva, do you have any friends in the science class on like WhatsApp or anything?
Yeah.
Could you send them a message? The message is, please ask Colin if he got Stephen's text. Simple as that. Colin is the worst teacher for replying to texts in that he doesn't. Okay, in a moment we'll have a look at number 4. Sent? Who's your contact you sent it to, or was it to the group?
Both.
Oh yeah, but I mean, like, is it a WhatsApp group, or, so, did everybody see it?
No,
That's not a problem.
Yeah.
Oh yeah, but potentially how many people could see it?
I see it.
Wow. 2.
Only two. Oh, we
Oh,
hope.
you mean like the health science?
Yeah. Well, they would be in Colin's class too. But could you send it to the health science?
I don't think I only know.
Okay, no problem. You only know 2 science students. None of you know health science
I
students?
think I do.
You do?
Yeah.
How many?
Oh,
A few.
The WhatsApp group?
I can text them and tell them to let the class know.
Please. Well, no, I simply want to know if Colin got my text message,
Okay.
that's all. Okay. When you're ready now, we'll have a look at number 4.
Can't stop.
Hmm?
Can't stop.
Where are you stuck?
Omega equals to square root 9 over.
A squared minus 4. Where did I get that from? I got that from this line. And I got that one from this line, which I got from here. That's from here. Number 4. Problem? You guys giggle a lot. I don't know what you're talking about all the time. Are you not going to share with me?
Too sleepy.
I know that. No, I know that. I know that. Okay, 4. Right. The mass of the Earth is that. The asteroid that killed the dinosaurs was about that big and was traveling at that speed. And when it hit the Earth, it caused it to wobble. So look, this is what's happening. You have the Earth, you have your asteroid, comes in, hits the Earth, crashes into the Earth, and then what happens? The Earth begins to wobble a little bit. Just a little wobble here. And
Really?
true, yeah.
Is it really wobbling?
Yeah, really. Yes, still, yeah. This is called the Chandler Wobble. So the see, but it's not like it's a big wobble. It's 1 meter. Now, I know that seems like a lot, but when you compare it to the size of the Earth, it's not. So it's as it's moving in a circle, roughly, around the sun, it's also wobbling too, like like something that's kind of shaking a little bit, like a spring. So we kind of picture the Earth as fixed, and it's rotating, and it's moving around the sun, and it's also tilting slowly back and forth. But in addition to this, it's also wobbling as it's going back and forth. So there's lots of motion happening here. So my question is, what is the frequency? So how quickly is it wobbling? So 1 hertz would mean it's wobbling kind of slowly. 2 would be faster. How can we work this out? This is kind of a tricky one because it doesn't seem like I gave you a lot of information, does it? But think about this. This asteroid had kinetic energy, right? But when it hit the Earth, it came to rest. Where did this energy go?
Yeah.
It went into the Earth as a potential energy to cause the wobbling. So it's almost like the Earth is a spring. The asteroid hits the spring and fills it with energy and makes the spring move down. So you can actually say a half the mass of the asteroid times the velocity squared equals the potential energy. And what was the formula? It was a half omega squared a squared.
S.
Yeah, so we're looking at the situation where all of the kinetic energy went into all of the potential energy. Oh, and that M is that should be a capital M because it's the mass of the Earth. A half M omega squared a squared. Isn't that it, the formula?
Mm-hmm.
Yeah? Now, the halves cancel. We can't cancel the M's. I'll look for the omega. Oh, what's the amplitude here? The amplitude is 1 meter. Yeah? So now we have the formula m v squared equals m omega squared. So omega is square root mv squared over m, which is square root, what's the mass of the asteroid? 4.6 times 10 to the 17. Well, how fast is the asteroid going? 20 kilometers per second. Is that a reply? Oh, nice.
He said I'll ask him after class.
After? No. It needs to be during, because he has to deliver a message to my students.
Well, I think he told me he has no rain now.
Oh, he does not call them?
No.
I thought if we're in physics and they're in biology. Is that not how it works?
I don't know, because I saw him before he went to class. And he has the rain.
Masters should have column, right?
Yeah, they should have color, or
They
they
should
already
have
have.
biology profile group. Yes, he already sent it to the group, so maybe they should see it.
Yeah, they should.
Who is this friend? Does he know what's going on?
No.
Okay, no, never mind. It's okay. Thank you anyways.
No, I told him, ask if Mr. Collins wants to receive his message.
And he said, I'll ask him after class.
Yeah.
No, never mind. It's okay. It's okay. I just have to accept that Colin doesn't reply to me. 5.972 times 10 to 24. Oh, and it's a square there. So that's the omega. Could someone hit that in? Get the omega at least. That's a 24. Because once you have that, we can say f equals 1 over t equals 1 over 2 pi over omega. So that will equal omega over 2 pi, which will equal
10 to the power 24?
yeah.
17.5.
Okay, so this is our answer here, which is 0.883 hertz.
So what is that? 2 pi over.
Omega. Number 5? Yeah. Okay, number 5 is kind of a hard one as well, and so is number 6. But the bad news for you is both 5 and 6 could be and have been exam questions. Yeah. So 5. Could be and have been. A car bobs up and down because it hits a speed bump. So what you have is you have a car and it's on its spring, obviously, and it hits a bump on the road. So here's my car, okay, and when it hits the bump, the car goes up and down, okay. And I actually tell you the amplitude. The amplitude is 0.05 meters. Now, let's imagine. So here's the car and here's the person, I guess, and the car hits the speed bump. And it goes up and down. But you understand if it moves oh japers. It's okay. If it moves quick enough, the person actually lifts off their seat. You know, if it goes fast enough, the person actually ejects from the seat slightly. So we want to figure out how fast? What's the frequency? So obviously, if it's 1 hertz, 1 hertz is just like this. Do you think the person will leave a seat? Okay, 10 hertz would be like this. Yeah, they probably would lift up off the seat. So there must be some point at which they lift off their seat. We need to figure out what that point is. So let's zoom in. Here's the person sitting down on the seat. What are the forces on this person? They have 2 forces. They have a weight and a reaction force. Okay. Now let's just make the picture a little bit easier in our mind. Let's just imagine that it's hit the speed bump, it's gone up, and now we're looking at the picture when it's on the way down. So if this is going down fast enough, then the person will not be in contact with the seat. So imagine, here they are, this is slow motion, okay? So they're sitting here, it hits the speed bump, the car goes up, and then it comes down, and then they fall, and so they feel like they've left the seat. So my question is, what's so special about this? What is the equation we could make for the situation when this starts to happen? Now this isn't obvious, but what could it be? Might have to do with potential energy, yeah. It's more to do with acceleration. So I'll tell you because it's not obvious. If this falls faster than g, so if this is going so fast, it's falling faster than 9.81, then what will happen is he will no longer be in contact with the seat. So like, if this goes down with 10 meters per second squared, then it's falling faster than he's fallen. So the contact is left. Okay? So what you want is the situation where the maximum acceleration from the simple harmonic motion is more than g. That's the situation. Now you see, that's tricky. But now that I've shown you, maybe you'll remember it if it comes up in the exam, that this is kind of the trick here. We have the formula for this, do you remember? It's a omega squared, wasn't it? Yeah. And that needs to be bigger than 9.81. But we know the a, it's 0.05. So the omega needs to be bigger than that. So what is that, please?
Colin said he doesn't have his phone.
Oh, typical.
So therefore the text has not yet reached him. And it will.
Colin, you're useless. Now what do I do? Oh, he's so... Oh. Now I don't know what to do. Who was it that sent you that message?
And you.
Should I tell him to tell them? Should I say to tell him he's useless, or should I? Do you mind typing a message, please? Thank you. The message is: tell the health science students they will have a resit maths test this evening.
They're not that bad?
No, I'll explain in a moment. Just double checking. Just read it back to me.
So the health science students, they will have to use the math test this week?
You can say that was the text message. Just add that at the end. Yeah. No, see, but what happened was they did the test on Moodle, and they were complaining. They're like, well, oh, it didn't take my answer, or I thought blah 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 blah, whatever, well. So, yeah, you can send that. So I'm letting them redo it, so they don't feel like they didn't have a good chance to prove themselves. That's what it is. So they did the test on Moodle, but Moodle crashed. but it crashed during their second attempt at the test. So they're all like, but I did better the second time than the first time. I'm like, okay, leave me alone. So I'm giving them a chance to redo it. Okay.
So the question is different from us.
Yeah, I typed up the questions this morning. So the test that they did and the resit test, they're different tests to what you did in maths. You're welcome to try the test too, just to try a different test. I put it up on Maths Part 1 page. I'm going to open it at maybe about 4 o'clock this evening.
Is your math different?
Not in semester 1. Yeah. What did we get for omega?
14.
14? Exact?
14.007.
Okay. So the F, I was looking for the F. That's 1 over T, that's 1 over 2 pi over omega, that's omega over 2 pi, that's 14 over 6.28. So what's that? .859 hertz, is it? So look, that means if the, what is it?
Yeah, that's like that.
Oh yeah, sorry, yeah, that's not right. Yeah, what is it? 2.23. So look, what I'm saying is, if the frequency of the car's vibration when it hits the bump is more than 2.23 hertz, then that means the passengers will actually leave their seat. I think that's interesting. So, you know, if it hits a bump and it goes faster than 2.23 hertz, then the people will feel like they've left their seat. Maybe even hit their head off the roof. Yeah? You've all been in a car, well, maybe not you, Steve, but you've all been in a car where you hit the roof when you hit a speed bump.
Twice, I'm sure. I have hit the...
Have you?
Yeah.
Good for you. Good for you. You all know the phenomenon I'm talking about, yeah? Yeah. Well, I forget in the Middle East they drive more recklessly as well.
Yeah, I have been there.
Probably hit the speed bumps a bit faster too, isn't it? Yeah.
They do that on purpose sometimes.
Yeah, they do
Really?
that. Yeah, my
Really?
brother does that on purpose.
Who does?
My brother.
He does. It goes fast through the speed bump, just for the fun of it.
So I can have
Oh, shapers.
He's a good guy.
Oh.
Right, what are we on now? Number 6, okay. Can we do number 6 now? Now, number 6 is a little hard as well. A harbour, you all know a harbour? Like where you put the boats? It's 2 meters deep. At low tide, which is 7 o'clock, it's 2 meters deep at low tide. So at its lowest, it's 2 meters. And then 12 hours, that's at 7 o'clock. And then 12 hours and 25 minutes later, so what's that, at 19:25, it's at low tide again. So it's at there at 19:25. A boat is at the dock at 7 o'clock and requires the depth to be 5 meters. So you see this sometimes in the harbour. You have boats, and when the tide is really low, it's stuck in the sand. So it can't actually move because the boat is bigger than the water level. I don't know if you've ever seen this. I used to live in a sailing town, like there was lots of boats. So you'd see at low tide the boats are actually stuck into the sand in the harbour. So this boat is not going anywhere until the water is high enough, which in this case needs to be 5 meters. Now, you're told at high tide, that's 10 meters. Now, it doesn't need to be this high, but that's the high tide. So, the water is actually moving, believe it or not, in simple harmonic motion. It's just moving really, really slowly, but the tide is actually going up and down in simple harmonic motion, but the time is huge. It's like really long time. You can't really see it. The time is 12 hours and 25 minutes. So that's 12 hours and 25 minutes. We should convert that into seconds. So that's 12 times 3600 plus 25 times 60. What's that?
44,700.
Okay. Now, just be careful here. It goes from 10 to 2 meters. What's the amplitude of this motion? Nearly, not 10 minus 2 is 8, but it's not quite 8. What's the amplitude? You have to do one extra thing to that. Yeah, divided by 2. It's 4 meters. So here, the amplitude is 4 meters. Yeah? So at the beginning, the x is equal to what? It's equal to 4, isn't it? And then, Is it? No, I think this is it. It's okay. So it starts off at 4, then minus 4, 3, 2. Now I'm going to call this positive and this negative. So it goes 4, 3, 2, 1, 0, 1, 2, 3, 4. And it's doing simple harmonic motion back and forth like this. Okay? We need, how much do we need? 5 meters. So 5 meters is like here. What's that distance? If this needs to be 5 meters, that's 5 meters. Here to here is 4 meters, isn't it? So what's this distance? 1 meter. Okay, so we want to know when will x equal 1 meter. So if we use the formula x equals a cos omega t, we get 1 equals 4 cos omega. Did we work out omega? No, but it's 2 pi over, no, I have that the wrong way, didn't I? Omega is, omega is 2 pi over t. So that's 2 pi over 44700 t. Okay, nearly finished. So that's 0.25 equals cos 2 pi over 44700 t, because divide by 4. So finally, well not finally, you can do cos inverse. And then you can get t is 44700 over 2 pi cos inverse 0.25. In radian mode, what do we get? Seconds. Now we have to work out how many hours that is. Could you divide that by 3,600? What do you get? 2.6 hours, which is 2 hours and 3/5 of an hour. How much is 3/5 of an hour? 36 minutes, is it? Yeah. So that's 2 hours and 36 minutes. Low tide is at 7 o'clock. So if we start at 7, then it'd be 9:36 is the answer. You got a reply?
Yeah. Colin has seen the message and his reaction was a mixture of negative surprise and mild indignation.
Just reply lols. LOLZ. Stephen says lols. LOLZ.
The formula, can I use because
Yes.
it starts at the lowest,
Yeah.
not the equilibrium, so you can use the other equation.
The cost one.
Yeah.
That's what I did use, cost. Yeah. Yeah. Did you say lols or Stephen says lols?
Yes, you would say lols.
Okay.
Because it's not my thing to say.
Yeah, exactly. That's good. Yeah, yeah. As in quotation marks.
See the diagram?
Mhm. What's up?
We're conversing in Korean.
You know some Korean? What do you know? The bad words? Have you not taught her any bad words yet in Korean?
I already knew that.
All right. Did you write this down? Yeah. Once you write that down, we'll finish with this. Can I close this? Matt? You're looking very deeply at this. Is it okay? Are you sure?
I will do that.
Okay. That's all the simple harmonic motion questions done. They were pretty hard, huh? We still have 2 minutes and 10 seconds left, but I think that's okay.